This is a three-dimensional cube. 6 square faces enclose it. It has 8 vertices. Then, what shapes enclose a 4-dimensional hypercube? How many shapes enclose it? And how many vertices does a hypercube have? You haven't seen it before, so you don't know? Let me show you. Here it is. This is another picture of a hypercube drawn by DALL-E. Jesus is hanging on it. I'll show you in a video. Now, do you figure it out? Even with pictures or videos, it's impossible to fully represent a hypercube. There's no way for our eyes to see it directly as well. But figure out the pattern and the process by which the hypercube is formed, and you can catch a glimpse of the secret of the hypercube. First, let's look at what shapes form the boundary of a hypercube. A point has no parts, so it has no boundaries. The number of boundaries is 0. A line segment is formed by pushing a point in one direction, and the 2 points become the boundaries at the ends. There are no other boundaries. A one-dimensional line segment is enclosed by 2 zero-dimensional points. A square is formed by pushing a line segment in another direction, and the 2 lines become the boundaries at the ends. However, at the boundaries of this line segment, which are points, 2 line segments are also created. A 2-dimensional square is enclosed by 4 one-dimensional line segments. A cube is formed by pushing a square in a third direction, either up or down, and the 2 squares become the boundaries at the ends. In addition, 4 squares are created at the boundaries of the square, forming the boundary of the cube. A 3-dimensional cube is enclosed by 6 2-dimensional squares. A hypercube is formed by pushing a cube in a 4th direction, which we can't experience, so 2 cubes become the part of the boundary. Moreover, in each of the 6 squares that were boundaries of the cube, another cube is created. These 6 cubes also form the part of the boundary of the hypercube. A 4-dimensional hypercube is enclosed by 8 3-dimensional cubes. That's why DALL-E drew a hypercube this way. Take a careful look. There are 8 cubes. The boundary of an n-dimensional shape is an n-1 dimensional shape, and the number of such shapes is 2 plus the number of boundaries of the n-1 dimensional shape. It is equal to 2 times n, the number of dimensions. Now, how many vertices does a hypercube have? Let's find the pattern. A 0-dimensional point has 1 vertex. A 1-dimensional line segment is created by pushing a point, so the number of vertices doubles. It's 2. A square is created by pushing a line segment, so the number of vertices doubles again. It's 4. A cube is created by pushing a square, and the number of vertices doubles as well. It's 8. The number of vertices doubles from the previous dimension. As a result, it is equal to 2 times the number of vertices of previous dimensions, that is, 2 to the power of n. This is the pattern. Thus, the number of vertices of a hypercube is double that of a cube. It is 16. Now, look at the hypercube again. You'll be able to see things that you couldn't see before. Thank you.